Hey, Fort being tutoring, 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 tutormemath.net. Fort being tutoring, Fort being tutoring.
Hello, ladies and gentlemen. This is Mr. Witt with Fort Bend Tutoring, and today's tutorial is going to be about finding the slope of a linear equation. So let's check it out, ladies and gentlemen. Note that the common variable used for the slope is m. All right, so when you see m in most equations, in most formulas, we're dealing with the slope of a linear equation. All right, and the definition of the slope is the change in y divided by the change in x. So we sum that up generally in the simply saying it's the rise divided by the run. So in essence, anytime you see this symbol here, by the way, this triangle in mathematics, it's the delta symbol, the Greek symbol delta, and it means change. So when you're dealing with a slope, you're looking for the change in your y values divided by the change in the x values. So there you have it right there, change in y divided by the change in x. And you can sum this up even further. You should know that when you have a positive slope, that your line, your linear equation, will rise to the right. When your slope is negative, it will rise to the left. And when you have a slope that's equal to 0, you're dealing with a horizontal line. And then even further, when your slope is undefined, when you don't have a slope, that means you're dealing with a vertical line. Just like that. All right. Now, your slope formula. Here we go. Your slope formula, remember we said that the slope was the change in y divided by the change in x, right? That ratio. Here, your formula shows just that. M, which is the common variable for the slope, is equal to y2 minus y1 divided by x2 minus x1. Or in layman's terms, the y value of the second point minus the y value of the first point divided by the x value of the second point minus the x value of the first point. So this is what we'll be focusing on today, dealing with finding the slope, and at the end I'll even have a gradient problem. That's right, finding the grade. Okay, so there you go. Let's take a look at some problems here. In problem number 1, we're given a graph with a linear equation, and we have 2 points already identified for us. We have the point 4, 0, as well as 0, negative 3. Now recall our slope, or the variable m, is going to be equivalent to the rise divided by the run. Okay, so what does that mean? Well, what I normally do is I'll just start with my furthest to the left point that's given, and I'll see how far it takes me to get on the same level as the second point that's given. So for instance, I'm going to find out the rise first. So starting from this first point of 0, negative 3, in order to get to the same level as the point 4, 0, I'm going to have to go up 1, 2, 3 to get to that 0 mark on the y-axis. So therefore I went up 3 places. Then from this point over here, I'm going to have to move over to the right, or run 1, 2, 3, 4 places to the right. Okay, so I'm left with 3/4 as a result. That's it. Okay, so anytime I'm given a graph here on a Cartesian plane on the rectangular coordinate system, and I'm given 2 points, or you locate 2 points on that graph, then all you have to do is see how far you need to go up or down to get to the second point, and then how far you had to go to the left or right to get to that second point. All right, and then that becomes your rise and your run. And note that since we went up, our 3 is positive. If we had to go down to get to that second point, it would have been a negative value. And then because we went to the right to get to our point 4, 0, that was a positive 4. But if we had to go left to get to the second point, it would have been a negative 4. All right, so keep those things in mind. And here I'm going to box up my answer. So that slope is 3/4 for problem number 1. All right, let's continue on. In problem number 2, we're given 2 points on a line. So if their question is to find the slope, then given these 2 points, your first step is to label the points. So I'm going to label my first point x1, y1, and the second point x2, y2. This means that the first x value is going to be 1, whereas my first y value is 2, and the second x value is 3, whereas the second y value is 5. And we're going to use these labels in the formula for our slope. Remember, our slope formula is m equals to y2 minus y1 over x2 minus x1. So here, we'll start plugging these values in. So I know that my y2 value is 5, minus comes from our formula. Always make sure you have a minus sign there. Our y1 value, which is 2, divided by 3, our x2 value, minus, coming from the formula, our x1 value, which is positive 1. From there, we'll go ahead and simplify this. We know that 5 minus 2 is 3. And then 3 minus 1 is always 2, and this is my slope for problem 2a. Just like that. Okay? Just like that. So we're going to use this same procedure in our next problem. That's right. In 2b, we have the 2 points 4, -3, as well as -2, -3. All right? And your first step is to label. So I have my first point labeled as x1, y1, then x2, y2. See, these subscripts look a lot better in this problem right here. So you can see how they're positioned, all right, to the right and down, okay, as far as the position is concerned. All right, so those are subscripts. Now that we have those points labeled, go ahead and use your formula. And you know what? It's always a good idea to write down the formula every time you use it. So here I have my slope formula, that's y2 minus y1 divided by x2 minus x1, and now I'm going to plug in my values, all right? So plug it in, plug it in. Yeah, plug it in. So you'll have -3 minus my y1 value, which happens to be a negative value. So that's why I'm using parentheses to ensure I'm aware of the fact that my y1 value is negative, but also I have a minus sign coming from the formula for the slope formula. Okay, so that being the case, I'll end up with -3 inside the parentheses here, and all of this is going to be over my x2 value, which is -2, minus, coming from the formula here, my x1 value, which is 4. Okay, from here, we'll simplify. That's right. And I'm going to start by combining these signs in the numerator. I know that a negative times a negative will be a positive result here. So this rewrites into -3 plus 3 over -2 minus 4. From there, combining -3 and +3, these additive inverses, these opposite values, you'll end up with a result of 0. So this will be 0 over -2 minus 4, which is -6. Now, anytime you have 0 over any number other than 0, the result is 0. All right, so there you have it. And remember, anytime you're dealing with a slope that's 0, you're dealing with a horizontal line. So just from solving from the slope and knowing that my slope here is 0, I'm aware that these 2 points lie on a horizontal line. In fact, you should notice that in the original problem here. Notice how the y values are the exact same. So anytime your y values are the exact same, you're dealing with a horizontal line, and because you're dealing with a horizontal line, the slope will always be 0. All right, so tips to keep up with. Let's continue on. All right, so here we have 2C now. And in 2C, we're going to go ahead and label once again. Now notice our x values are the same. So do you know what that means? Do you? Yeah, you're going to end up with a vertical line. But let's prove that using the slope formula. So we'll start with labeling x1, y1. We have our second point labeled as x2, y2. All right, those are some ugly 2's, but we're going to be okay. And then, using my slope formula, we're going to always write it out. M equals to y2 minus y1 divided by x2 minus x1. All right, and then we're going to plug in our values here. We'll end up with our y2 value being -7 minus my y1 value of 4, all divided by the second x value, which is -2, minus the first x value, which is also -2. So I'm going to use parentheses to show that. All right, so remember, I always want to make sure that the minus signs from the formula are still present after I substitute. Okay, that being the case, I'm going to combine these signs right here. I'll have -7 minus 4 over -2 plus 2, and guess what? I end up with -11 over 0. Okay, now, ladies and gentlemen, you should know that anytime you have 0 in the denominator of a fraction, that's undefined. It doesn't make sense. So therefore, you end up with a result that is either no slope, you can write no slope, or you can use the null set to say that it's undefined. It doesn't exist in this problem because it's a vertical line. All right, so you don't have a slope in this problem. It's undefined. All right, and some teachers will want you to write the words no slope. Okay, so there you have it. That is problem 2C. Moving on to our next problem, we have 2D here. And in 2D, we're dealing with 2 points that have fractions in it. Right. I know you love fractions, so let's get to it. So you're going to start out with the first step. So we're going to label our 2 points here. I'll have x1, y1, x2, and y2. All right. Now after we label, what's the next step? Write down the formula. That's right. So I'll have m equals to y2 minus y1 all over x2 minus x1, and then I'll replace these variables with the values that I have for my 2 points here. All right. So my y2 value is going to be 3/11. It sure is. Minus my y1 value, which is also 3/11. Uh-oh. The two y values are the same, so we're dealing with a horizontal line, aren't we? So now we have 5/4 for our x2 value minus our x1 value, which is a negative 1/2. So I'm going to show that using parentheses here. Well, ladies and gentlemen, you will end up with 0 in the numerator. All right. And yeah, in the denominator, this is 5/4 plus 1/2. And yeah, you can go ahead and get an equivalent expression that reads 5/4 plus 2/4 to give you 7/4 in the denominator here. But we have 0 in the numerator. Anytime you have 0 in the numerator over any number other than 0, the answer is 0. So that means that my answer is 0 here. So once again, once we recognized that those two y values were the same, you should know that you're dealing with a horizontal line. Okay, so therefore the slope is 0. Done and done. Let's move on. Let us move on. All right, we have more problems to show. All right, so here we have it. In problem 3, we're asked to find the slope, right? We're asked to find the slope, but yet they've given us a linear equation. So with this linear equation, y equals to 4x plus 11, please be aware of the slope-intercept form. What is the slope-intercept form? It's this y equals to mx plus b form. Oh yeah, because when you're dealing with the slope-intercept form for a linear equation and y is solved for, the coefficient in front of the x variable, that means that number in front of the x term, it's always the slope. It's always the slope of the linear equation. So therefore, what's my m value here? Okay, that's right. It's 4. It's 4. The slope, m, equals to 4. There you go. That's it. I'm putting a red box around my answer. That's the end of that problem. That's all you have to do there, ladies and gentlemen, is just identify the m. That's right. Make sure y is solved for, okay? So make sure you already have it in slope-intercept form, and once you do, oh yes, the slope equals to 4 in this case, and there you have it. All right, that was problem number 3. That was fun. That was fun. Here we have problem number 4. All right, so for those of you that were saying, well, Mr. Witt, what happens when you have the linear equation already in standard form? How do I extract the slope? Well, let me show you. What you want to do first is you want to solve for y. Okay, so we'll solve for y first by subtracting 3x to both sides. I love me some algebra. And then I'll be bringing down 2y, which equals to negative 3x plus 6. Yeah. Then, to continue isolating your variable y, I'll be dividing everything by 2. Okay, so I'm going to divide everything by 2, dividing everything by 2 right here. I end up simplifying this to end up with the following. I'll have y equals to negative 3/2 x plus 3. You got it. And once I have this, notice that I do have this in our slope-intercept form, which, for a reminder, is y equals to mx plus b. Yeah, that's the slope-intercept form. And I want that m value. That's right, the coefficient, the number in front of the x variable is your slope. So that means that in our equation here, the slope is equivalent to negative 3/2 and done. That's it. That's it. Our slope is negative 3/2 for problem number 4. So when given a linear equation that is not already solved for y, solve for y. And then once you have it in slope-intercept form, the coefficient in front of your x variable, that's right, is going to be the slope every single time. Every single time. That's right. Okay, let's continue on. Here I have problem number 5. And in problem number 5, we have the equation y minus 4 equals 0. This is a linear equation. It is a line. I need to find the slope of it. So what I'm going to do is I'm going to start by solving for y. So I'm going to add 4 to both sides of the equal sign here. That's right, the addition property of equality. And I end up with y equals to 4. Once I have y equals to 4, you should recognize that this is a horizontal line. Why is that? Because anytime you have the format of y equals to a number, it's always going to be a horizontal line. Every single time. So anytime you have an equation in the form of y equals to a number, a constant, this is always a horizontal line. Every single time, ladies and gentlemen. And what's the slope of a horizontal line? Absolutely. It's 0. It's 0. So the slope is 0. Remember, that's what they wanted us to find in the first place. They wanted us to find the slope. And by recognizing that you were dealing with a horizontal line, that means that you end up with a horizontal line done and done every single time. All right, let's move on to our next problem here. Okay? In problem 6, we have the following. We have x equals to negative 3. Just like our previous problem had a form that you should recognize, that's the case in problem number 6. The form that you should recognize is that anytime you have an equation of the form x equals to a number, you're dealing with a vertical line. You're dealing with a vertical line. And anytime you're dealing with a vertical line, that means you don't have a slope. The slope is undefined. So once again, you can write your answer as no slope, or you can just simply say that the slope is undefined. So depending on your instructor, your textbook, your class, you can have your answer written either way. Okay? So the slope of a vertical line does not exist. That's why you can say you have no slope, or you can simply state that the slope is undefined, because it is. All right. So recognize when you're dealing with a vertical line or when you're dealing with a horizontal line. A vertical line has no slope, whereas a horizontal line has a slope that's 0. Yep. Okay, so as promised, I said that I would have a gradient problem here. And what is the grade of this ramp? The grade is simply the slope represented as a percent. Here, when you're given a problem like this, when they say, what is the grade of this ramp? And we can see clearly that we have a horizontal distance of 5 and we have a vertical distance of 2. Remember that the slope is the ratio of the rise divided by the run. So in this case, we will rise up 2 feet here as we run across 5 feet. And since we know that the grade is the slope expressed as a percent, okay, you see that at the bottom there? I have a note there at the bottom. The grade is the slope expressed as a percent. In order to convert this fraction into percent notation, all you have to do is multiply by 100 over 1. So let's do just that. All right, so a little fraction conversion into a percent. All right, we are going to simplify our 5 and the 100, right? So 5 goes into itself once, whereas 5 will go into 100 20 times. Then multiplying straight across, you'll have 2 times 20, which is 40 over 1%, which will simplify further into 40%, which is the answer. That's it. So the grade of this ramp is 40%, ladies and gentlemen. Done and done. That is a gradient problem. That is how to find the grade, all right, which is also the slope represented as a percent. So we have a 40% grade. Okay, so there you have it, ladies and gentlemen. Done and done for problem number 7. And that also concludes this lesson on finding the slope of a linear equation, ladies and gentlemen. This is Mr. Witt with Fort Bend Tutoring, FBT. Please rate, comment, and subscribe. Peace.
So what you waiting on? Everything is online. Just hit the website, they even got FaceTime. Subscribe to the YouTube, request the video. Watch your math skills go from alright to incredible. They got math, got algebra, got geometry. Pre-cal calculus, can't forget trigonometry.